So this second half of this session will cover the OpenStack QA tooling and how we can use that for the production cloud testing. So my name is Ghanshyam Mann. In IRC you can find me the Gman. So I'm open source developer in NEC, involved in OpenStack since 2012. Initially as a user and operator, but from 2014 I started the upstream development. Currently I'm a member of the OpenStack technical committee and serving as PTL of OpenStack QA. I'm doing a contribution in NOAA, infra, like the Joule jobs on OpenStack project side and first contact SIG. You can find more details on my website there. So as a quality assurance, our main mission statement is we develop, maintain and initiate the toolings plus the test cases for the upstream stability and the quality of OpenStack. So every release, every day, whenever the patch is merged, so the OpenStack QA toolings and the test case, we keep running through the Joule jobs. And along with that, many companies using a lot of QA toolings in their production cloud testing also, which we'll be covering next. So these are the all QA tools we have. Some are like for development perspective only, like for DevStack. On the left side you have, which create your DevStack development environment for upstream patches and Joule jobs. We have few for test results. OpenStack Health, it's gives the graphics view of your Joule jobs and the test their test data, is pass or fail. We have a couple of test framework like Tempest, their plugin, Granite for upgrade testing, Patrol for RBAC testing. We'll be covering in next slides. And all others are like especially used for the development environment only. So if we talk about what all tools we can use from it on production side, so I picked these four tools. And one is Tempest, you might know, and its plugins. So Tempest is an integration testing tool. It provides a framework to write the Tempest-like test. Tempest-like test is nothing but calling your OpenStack APIs, interacting with different services, and verifying the behaviors. So there is no, like, other than APIs, Tempest doesn't talk to any of the services. And plugins framework. So Tempest has 6 services test case in tree: NOAA, Cinder, Neutron, Glance, Swift, and Keystone. And for all other OpenStack projects, we provide the plugins so that they can write their own test case. But as a user, if you see, you can run all these Tempest or their plugin test with a single command. So it's just the location of the test case is different, but from the user perspective, there is no difference on that. Second is Patrol. That is the new tool introduced, I think, two years back. So Patrol is the security validation tool of verifying the OpenStack role-based access control. So as you know, like OpenStack APIs has policy enforced on each API's operation, where you can control, okay, this user has access to this API and this user cannot access to that API. So those policy things are being tested by Patrol. How it testing we'll cover in the next slides. The fourth one is OpenStack Health dashboard. So that is giving you a visual view, graphics view of your test runs, all the data, right? Whatever the Tempest test case has been run, what is the failure percentage, success percentage of specific duration you want to view. And StackWiz is also visualization utility. So the performance of Tempest run, especially you can judge like, okay, these many test cases ran in XYZ minute, all these things. OpenStack Health has two parts. One is they provide the APIs to collect the data from the test run things, and second is the graphic node they have, so they utilize the data. So let's talk about like how this is the usual OpenStack Cloud, which I'm not going to explain it, but this is how it looks like. We have the different OpenStack services like networking, block storage, compute, identity, and they all provide the RESTful APIs. So the user interact with RESTful APIs, perform the operation. So this is it looks like, and from it, if we see what all things we should test, like on our daily operation, what we should make sure like things are working, because we don't want failure when user is trying the operation, right? We want to make sure like everything is working whenever a user is performing any operation. Our cloud is in working state. Very first point is APIs, whether your APIs are working or not. Role-based access control. I talked about the policy thing, like the controlling on API operation based on the user roles, like admin APIs can only run by the admin or not. No other user can access those. So those are security things. Obviously, everyone wants to test on their cloud. And on the left bottom side on service status, like OpenStack each has a different services to provide the functionality. Like for computing things, we have NOAA API service, compute service, scheduler service. So all these services are running on different node or single node, depends on the cloud deployment. So we want to make sure like every services are running or not. Like if we have the 3 compute node, all the 3 compute services on those nodes are working fine or not. It's not be like, okay, only one compute node is running fine, 2 are down, and when we have the load from users, our cloud won't behave perfectly. Second is non-frequent scenarios. Like we have many features from OpenStack which are not so frequent. For example, one is the shelve instance. So you can shelve your VM, which will offload the image from your compute node and hypervisor. So sorry, those are not frequent features. So we want to make sure like those are also in working state. Whenever user request or any admin perform those scenarios, so they should be in working state. So we want to monitor those via the testing. And obviously the main important thing is integrated functionality. Like NOAA is perfectly working with Cinder or not, Neutron NOAA is working fine or not. So all these things. And last but not the least is upgrade. When you upgrade any of the node, when you upgrade your cloud, you want to make sure like everything working previously is perfectly working now or not. So these are the points, like very basic things we wanted to test. Performance and all these things are different, but this is all we wanted to test. All these things you can test via these 2 tools. One is Tempest and Patrol. So we'll go into a little bit deep in those tooling. Tempest has API test, scenario test. API and scenario both test interact with services via APIs. APIs test is verifying the API behaviors. Every API is working fine with the positive and negative ways. Negative ways in the term like when I call any API is like create server and I pass some invalid inputs, whether I'm getting a correct error or not. So that I can test it. I can verify nobody is able to inject the wrong inputs in my system. So API itself is denying those. Scenario tests are integration test. Like the services are dependent on each other, like NOAA, Cinder, Neutron, they're dependent, Glance, they're dependent to each other. So scenario test makes sure like a complete scenario is being performed. For example, server advanced scenario test we have. So we create a server, we attach the volume to that, we swap the volume, we check the network connectivity out within the tenant or outside tenant. So all these a complete scenario operation are being performed by scenario test. And in Tempest we cover Nova, Cinder, Glance, Neutron, Keystone and Swift scenario testing and API testing. Other project test case is with the Tempest plugin. So every project has their own Tempest plugin. For example, Ironic. So Ironic has Ironic-Tempest plugin. Designate has their Designate Tempest plugin. So there is nothing but the test location is on the project side, on the plugin side. But when in terms of the running the test case, you can run them with a single command, Tempest Run. So this is the Tempest, like what it can test, and it can cover the API, it can cover your features are working or not, it can cover every services is working fine or not. For example, we have the scheduler test case, like you can boot a VM on a particular node, so you can test every compute node is working fine or not. On Patrol side, this is the RBAC testing. So as you know, we have the policies control on the API's operation. So we want to make sure like those policies are not broken anytime. For example, if there is a admin API, say live migration, and in your cloud you are giving access to admin users to do the live migration. So you want to test like any other user, non-admin are not able to live migrate my VM. So those kind of testing Patrol can do for you. You can configure your role, what you want to test on that operation, and you can verify whether that role, if that has access to that API, is able to access the API or not. If doesn't have access, is not supposed to have access to that API, it should return error. So that you can verify with positive and negative test case. So similarly with Tempest, it has currently 5 service test case: Nova, Cinder, Glance, Neutron and Keystone. Swift doesn't have policy thing, so it doesn't have Swift test case. And for other projects we have not implemented yet. So only the 5 projects it cover. So on Tempest side, there is few more details. So on Tempest, I have the link on the reference side. So there you can learn about how to install the Tempest and all. So in this case, I'll tell you the key points. One is it runs with dynamic credential and the predefined credential. Dynamic credential, what I mean is when you can configure Tempest to create the test accounts, test user, test projects dynamically, and it will clean up everything up once the test case is done. Second way is predefined credential. So you can define your own test credential in the account.yml, and with those credential, Tempest will run the test case. It will not create any other things. Tempest.conf, you can configure Tempest to tell like what is your cloud and how you want to test it. Like for example, pause VM is disabled in your cloud, so you can tell Tempest, okay, pause VM is not available, so Tempest will skip those tests. There are a lot of configuration options to configure the Tempest for each project. And to make it easy to use, we have the Tempest CLI. All these 5-6 CLI we have. Tempest Run, you can run the Tempest, and clean up, you can clean up all the Tempest resources if there are some left. And so all these CLI you can use very easily. Next, on Patrol side, Patrol is also based on Tempest plugin, and same design principle we use like for Tempest. And Patrol, how it work, like how it verify whether policy is working or not. So we'll take example of this create server. Say we have the Nova and we have this policy os_compute_API server create. And so what in Patrol you can do, you can tell Patrol to run for say member role. So member role, first thing it will do with the Oslo policy. This is the policy check engine in OpenStack. So you give a credential, say user, this is my user and this is my policy. So they verify whether that user has access to that policy or not. So in policy you have the check string, okay, users with user ID. That matches, it has access. That doesn't match, no access. So patrol first check the configured role with Oslo policy, whether that role has access to that policies or not. And on the second side, it calls the actual OpenStack APIs with that overridden role. So it will call the post server API with member role. Say for example, in your cloud, only admin is able to create the server. So role member call the API, patrol will call the API with member role, and it will say not authorized, 403 error. So that error patrol compare with this right side check of with Oslo policy. If both match, it means your policy is working fine in your cloud. If there is mismatch, then something is wrong. Either someone has corrupted your policy file, or someone has hacked your policy file, or something is wrong. So those things patrol can verify it. For example, if a member has access to create the server, so first it will check with Oslo policy, can it create it? They will say yes, and then patrol will check with actual API calls. If that is passed, both are matched, it will say the test case is passed. If API is not able to access and policy is saying you can access, then test will fail. So both way around it will verify the policy thing. And you can run simultaneously with multiple roles, with member, admin, reader, all these roles you can run patrol with. So now next is I would like to tell about the health node, like how you can run Tempest or patrol on a single node with multiple instances. So there is a workspace called. So you can create the multiple workspace. So each workspace will have their own files like Tempest conf, stester, log directory, lock, everything will be separate. So there is a Tempest init command which you can create the folder and which will register the workspace for you. So in each workspace, so if you go to the next slide, in each workspace you can run the Tempest Run command. So Tempest Run will run Tempest test case, patrol test case, Tempest plugin test case based on your Ajax. So every workspace can run Tempest separately with different configuration to test your single cloud or multiple cloud. For example, in this diagram, there is a 3 sites, say for site 1, OpenStack site 1, 2 or site 3. And you want to test all these sites with a single Tempest node. You don't want to install Tempest in multiple nodes and test it. So you can create single node, install Tempest, create multiple workspace, and then run the Tempest for each site. You can get the results. And on the green side, OpenStack Health board, it will collect the test case result and show it into the graphical view. So with this, if you observe, when in case of the upgrade, if OpenStack sites are upgraded, say Rocky to Stein, you don't need to upgrade the health node. Whatever the Tempest was there, you can still keep running and compare previous result and after upgrade result. You can verify like, okay, my upgrade is not broken, or OpenStack upgrade, OpenStack next release has not broken anything. There is no backward incompatible change. So until you explicitly want a new test, you can upgrade the Tempest. Otherwise, with the same set of Tempest, same set of configuration, you can test your cloud before and after upgrade and verify whether your upgrade is fine or not. This is the OpenStack Health dashboard view. So when, for example, when every workspace, you can collect the data and show into the OpenStack Health dashboard. So this is the graphic view. Each job, you can check the pass rate, failure rate, and on the bottom side, like you'll have the graph, like which is going red or blue, all these things you can observe. So if any of the test case or any of the job is going more failure side, so you can get triggered like, okay, you can get the alert, this operation is something like, say for example, live migration test is failing, so something wrong is with the my live migration thing. So you can fix it immediately. So these things can be run periodically, every night, every hour, depends on your cloud, and you can collect the data and before user face the error, you can observe the error and fix it well before that. So because of time limit, we'll conclude it. Otherwise, we have the reference. So you can go to all these documentation and you can ask question on even OpenStack IRC QA channel. Yeah, that's all from me. Thank you.